Okay, Math Principles, here is a review. I did share version 1 of this review with you already, but I wanted to do version 2 as a video. So I'll post the PDF of version 2 along with this video in Google Classroom. Okay, so the first problem is solving each equation. So we have to solve this equation for x. So I'm going to rewrite it down below. Now, I'm going to go pretty fast through this video, so make sure that you pause and first try the problem on your own, and then you can kind of like skip through my work for the problem to see if you did it correctly, and then you're able to check your work that way. You don't have to sit there and watch the entire video, but you can skip through the parts that you actually need and see how you did on your problem, okay? So the first thing I'm going to do is distribute this 4 into these parentheses. So 4 times 8 is 32. 4 times x is 4x. And then I'm just going to rewrite the stuff on the left. So now I want to move all of my x's over to one side. And I like to avoid any negative x's. It doesn't really matter. Some students automatically would move things over to the left, but I recognize that I can add this 3x to both sides. And then I would end up with a positive x value on the right-hand side. So now I have negative 17 equals 32 plus 7x. And again, it doesn't really matter. Either way, you should get the correct answer as long as you deal with your negatives correctly. So now I need to move the numbers over to the left-hand side, the constants with no variable. So negative 72 minus 32 will be negative 49 equals positive 7x. And then we have to divide both sides by 7. So negative 7 equals x, and that is your answer. So this answer here will be A. Okay, so number 2, same exact thing. I need to solve that for the variable. So negative 6k minus 12 equals negative 8 times 4 plus 2k. And just always be careful if you're rewriting your problems onto another piece of paper somewhere, always double check that you wrote it down correctly. I see students accidentally write a negative for a positive or a positive for a negative, and then it really messes up their whole problem. So again, first I need to distribute this negative 8 into these parentheses. So this will be negative 32 minus 16k. You multiply when you distribute. Again, please pause if this is going too fast for you. Do the problem on your own and then check your answers with mine. So now here I need to move all the variables over to one of the sides. And here I'm going to go ahead and add 16k because I realize that'll leave me with a positive over here. Again, it doesn't matter. Either way you do it, you should get the same answer. So this will be 10k minus 12 equals, all that's left over here is negative 32. So now I need to move my constants over to the right-hand side. So I'm going to add 12 to both sides to get that away from the side with the 10k. So all that's left here is 10k equals negative 32 plus 12 will be negative 20. So if you divide both sides by 10, that will be 1k. So k equals negative 2. So your answer here would be B. All right. So number 3, it says solve each system by graphing. Now there's several ways you can do this. This one here is already set up in standard form. So you could either rewrite it as slope-intercept form, or you can plug in 0 to find your x and y intercepts. It's totally up to you how you want to do it. So let's see here. I'm going to first find I'm going to make this one here be my red line, okay? And this one down here will be my blue line. So for my red line, if I were to plug a 0 in for x and then solve for y, so this would be 0 plus 3y equals 12. So really I didn't need to write the 0 at all. I'm going to also, whoops, I'm going to rewrite that 3. That's a pretty crappy 3. There we go. And now if I were to solve for y, so I'm going to get y equals 4. Okay, so now I know that since this was my x, I know the point 0, 4 is on the red line. So I can plot this right here. That would be the y-intercept. So what I did here, I just want to show you again, is I plugged in a 0 for the x in order to solve for my y-intercept. So now what I'm going to do is I'm going to plug in a 0 for my y to solve for my x-intercept. So I'm going to have 2x plus 3 times 0 equals 12. So again, this is, you plug in 0 for the y to get the x-intercept. So this is just going to be 0. So I'm going to be left with 2x equals 12. Divide both sides by 2, we get x equals 6. So since this was my y, I know I have the point 6 comma 0 on my red line. And now you can see it kind of goes off a little bit. So that's kind of a bummer, but we can go ahead and put that there for now and see what ends up happening. If I draw a straight line, straight as I can, let's see if we're good to go once we plug in the other one. Okay, so now for the blue one, I'm going to plug in a 0, whoops. I'm going to plug in a 0 for x, okay? So now it's going to be 0 minus 3y equals negative 3. Now this 0, I don't really need it there, so I just have negative 3y equals negative 3. Divide both sides by negative 3. I'm going to get y equals positive 1. So since I plugged in 0 for x and I got 1 for y, my point 0, 1 will be on my blue line. Okay, so that one again was plugging in 0 for x, just like I plugged in a 0 up here for x. So now I'm going to go ahead and plug in 0 for y to get my x-intercept. So I'm going to have x minus 3 times 0 equals negative 3. So again, I had plugged in 0 for y to get my x-intercept. This just cancels out. Negative 3 times 0 is 0, so I have x equals negative 3. So that's simple enough. That means my point negative 3 comma 0 is my x-intercept because I had plugged in 0 for y. So negative 3, 0 will be right here. So now if we draw a point here, it looks like it won't be perfect, but it looks like I should be crossing right about here. And again, you guys can always use Desmos, you know, so like on Desmos, I would have had 6 comma 0 there, right? So let's look and see if that point, this would be 3 comma 2. Let's see if that's an answer choice. And it is, so 3 comma 2. And you know it can't be either one of these. Negative 3 comma 2 is way over here, so that's B. That's not good. 2, 2 is way down here. My lines weren't anywhere close to that one, you know, and no solution means that they would never intersect. That means they would be parallel. So our answer is definitely A. Okay. So now here we have these in slope-intercept form. All right, so my slope, I'm going to again, let's go ahead and give these some colors. So I'll have a purple line there, and then let's do a green line. Okay. All right, so the first one that I would plot is this is the y-intercept. So that would be the point 0 comma 2. So that's the first point I'm going to plot. And then if I know m is 1/3, this is rise over run because that's my slope. M is slope. Rise over run. So I'm going to go 1 up, 3 to the right. I can also even go backwards. I can go 1 down and 3 to the left. Or I could have done 3 to the left and 1 down if you wanted to make it look like the same slope triangle there. And it's a slope triangle because now if I were to draw a line through it, you see there's little triangles that are created there. Okay, so there's my line. This line is y equals 1/3 x plus 2. All right, and now here, this is my starting point, or my y-intercept, so that's 0 comma 4. So I'm gonna put that one right here. And then my slope is negative 1/3. So this is the rise over run. And it doesn't matter where the negative is. I just usually put it with the rise so I know. So from here, I'm going to go down 1 to the right 3. And that's perfect. That's my solution right there. Okay. So I know that my lines intersect right here at the point 3 comma 3. So that's what it means to be a solution. It's wherever the lines intersect at. Okay, so this one's answer will be D. All right. Solve each system by elimination. Okay, so I'm going to go and rewrite down the system. So negative 5x plus 2y equals negative 7, and negative x plus y equals 1. So I'm going to try to decide which one to eliminate. And it looks like I could really do either x or y, but I instantly was drawn towards the y's. I can multiply the bottom equation by a -2 in order to eliminate my y's. So I'm going to go ahead and do that. Multiply those by -2. So I'm going to rewrite over here, I'm just going to rewrite this one, -5x plus 2y equals -7. And then now I'm going to distribute -2, so this would be 2x. -2 to here would be -2y. -2 to here would be equals -2. Okay, so now I'm going to go ahead and work through the process of eliminating, and I can see right here I'm going to eliminate those two. All right, so process of eliminating is basically just combining straight down once you set up something to be eliminated. So these cancel out. 5x minus 2x is 3x. -7 minus 2 is -9. So now if I were to divide both sides by 3, I'm going to solve for x. X equals -3. Okay? Ruh-roh, did I make a mistake here? Should I have a positive somewhere? Hold on, guys. It says the answer is A, but it should be a positive or a -3. Oh, my bad. I did catch it. Okay, sorry guys. This would be a -3x. Oh, I'm so glad I caught that. -5x plus 2x is -3x. So I'd be dividing both sides by a -3. So this must be a +3. And now you see how I caught my mistake was because none of these x's were a -3. So I was like, okay, well, either they have to be -4 or it has to be a +3, right? So that is a good way to check your answer. So I'm glad I actually did that. So it would be a +3. So now I can just plug that into either of my equations. It doesn't matter which one. I'll just do it into the second one since it has less terms. So instead of the x here, I'm going to put my +3 here instead of x. That's where the x was. And then plus y equals 1. So this is -3 plus y equals 1. If you add 3 to both sides, we're going to get y equals a +4. Okay, so that means if my x is 3 and my y is 4, this is where the lines would cross on a graph. So my answer here is A. Sorry about that little mix-up back there. I'm glad I caught it though. Okay, so number 6. So same thing, it wants us to solve this by elimination. So if I have -6x minus 9y equals -18, 5x plus 10y equals 30. Okay, I'm looking at this and I'm like, okay, well, the 9 and the 10 on the y's would probably get pretty big if I tried to use those for elimination. So I'm just going to go ahead and multiply this top one by a 5, and then this bottom one here by a -6 to cancel out my x terms. And I'll show you how to do this right now. So I'm going to start distributing these. 5 times -6x will be -30x. 5 times -9y is -45y. And 5 times -18, that is going to be -80, I believe. My brain's not, oh no, 90. Yep, 90. Okay, so then it's going to be -90, oh, equals -90. Sorry guys, I'm tired. Equals -90, okay? So now I'm going to go ahead and distribute this -6 here. So -6 times 5x is -30x. Ooh, I need to multiply. Oh, I need to leave that as a +6. Otherwise, my x's will not cancel out unless that's a +6. Okay, because -30x plus 30x is 0x, so I need to leave it as a +6. So then plus 60y equals 6 times 30 is 180. Okay. So now going through the process of elimination, I know that I can eliminate my 30x's here. And -45y plus 60y is a +15y. And -90 plus 180 is +90. So now if I divide both sides by 15, I'm going to determine that y is equal to 6. Okay, because 15 times 6 is 90. All right, so now we know the y, and again, we can just plug that into either equation. I like the 5x plus 10y equals 30 better. So let's go ahead and plug in the y right into this equation here. So my y is 6. That's usually the y. That's 6. So I have 5x plus 60 equals 30. I'm going to subtract 60 from both sides. Oops. Okay, so I'm going to end up with 5x equals negative 30. So now if I divide both sides by 5, x equals negative 6. So my point of my solution would be negative 6 comma positive 6. So it's going to be B for this answer for number 6. Okay, so let's move on to number 7. It says solve each system by substitution. All right, so if I have y equals 5x, oh, actually, I don't need to write this down right now. So you guys notice that each of them is equal to y, right? So y equals 5x plus 11 and y equals negative 4x minus 7. So they're all equal to y. So I'm just going to go ahead and plug in 5x plus 11 for y into my second equation. So I get 5x plus 11 equals negative 4x minus 7. And now I have an equation where I can solve for x. It's the only variable there. So here I'm going to go ahead and add 4x to both sides. Again, there's several different ways to solve for a variable, so you do whatever you want. Please remember to be pausing the video because this is just to help you catch any mistakes or to check your answers, but you need to make sure you know how to do these on your own. So now I'm going to go and subtract 11 from both sides. So I have 9x equals negative 18. Divide both sides by 9. I have x equals negative 2. So if x equals negative 2, it looks like there's only one option. It's going to be answer A, but just to show you why, I'm going to go and take the y equals negative 4x minus 7, and we're going to plug in the negative 2 for the x there. We get y equals positive 8 minus 7, so y equals 1. So my solution is negative 2 comma 1, x comma y. So yeah, so it's answer A. So always still make sure that you work through the rest of the problem, because what if you had gotten like the negative 6 and just assumed that it was going to be that one, but if you had plugged it in, you probably would not get 1 as your y. So then you'd be like, oh wait, I should be getting 1 as my y, but I'm not. So then you'd want to go back and check your work for the x. All right, so this one's a slightly more difficult, but not too bad. So here it tells us that y equals 3x plus 21. So let's just plug in that y for this y down here. It's a system, so the y's are equal to each other, okay? So here I have negative 3x minus 7, and then I'm going to plug in my y. I know y equals 3x plus 21, and then that all equals negative 3. Okay, so I wrote out this equation and I substituted in this y value. So the first thing I need to do is distribute, so negative 7 times 3x and negative 7 times 21. So here I have negative 3x minus 21x minus 147, right? 21 times 7, yeah, 147, equals negative 3. So now I see over here I can combine these two. Negative 3x minus 21x is negative 24x. And then I'm going to add 147 to both sides. Okay, so this is going to equal, work for me, pen, 144. Okay, so if I see how many times 24, I believe it's, I'm trying to do some math in my head here. Yeah, 6 times. And you could use a calculator, I just didn't want to flip over to it. So if you divide both sides by negative 24, you should get x equals negative 6. And again, there's only one answer that has that, x equals negative 6, but I would like you to still insert it or substitute it in for one of the equations up here. So if we have y equals 3x plus 21, let's go ahead and plug in the x into this equation and make sure that we do get the 3 that's there in the answer choice A. So here, y equals negative 18 plus 21, y equals 3. So it should be the solution, negative 6 comma 3, and it is. Okay, so our answer is A. All right, so here we go. It says number 9, Catherine and Shayna each improved their yards by planting grass sod and I think you say geraniums. Those are flowers. They bought their supplies from the same store. Catherine spent $84. I'm going to start highlighting colors here. Catherine spent $84 on 12 square feet of grass sod and 4 geraniums. Shayna spent $54 on 5 square feet of grass sod and 8 geraniums. Find the cost of 1 square foot of grass sod and cost of 1 geranium. All right, so I'm going to use S for sod and G for geranium. So for Catherine, I know she spent $84 total on 12 square feet of grass sod. So I'm going to do 12 times S and 4 geraniums. So I'm going to use a G for geraniums. Let me make that look a little bit more like an S. There we go. All right, and then Shayna spent $54 on 5 square feet of grass sod and 8 geraniums. So here is our system of equations. We can start trying to figure out which one we want to eliminate, or we can try to use substitution. I personally would go for elimination here. You guys could also even graph these and see where they intersect on a graph. So what I'm going to do is I'm going to multiply the top here by a -2 in order to eliminate the geraniums there. So this will become 84, oh, I'm sorry, multiplied by -2. So this will be -168, if I distribute that, equals -24s minus 8g. Okay, and then I'm just going to rewrite Shayna's here. 54 equals 5s plus 8g. Okay, so I'm using the process of elimination. All right, so now if I do -168 plus 54, I'm going to get -107. This -107. -24s plus 5 is -19s, and then these two cancel out. So now if I do -107 divided by -19, I'm going to get, oops, that's not what I wanted. 107 divided by 19. Ooh, I get a pretty ugly decimal. Did I do something wrong here? I hope I didn't make another mistake. 84 times 2 is 168, yes. -8g. Trying to catch my mistake. So 168 minus 54. Oh, this is wrong. I must have typed it wrong into the calculator. This should not be 107. This should be 114. So -114. So now let's see if we do 114 divided by 19. This is what I get for using my iPhone calculator and not Desmos. That's why I'm opening up Desmos now, because it's easy to type in something by mistake and then not get the correct answer from that. So you guys just learned from me tonight. Yep, -114 and then 114 divided by 6. Okay, there we go. So I got 6 because my calculator earlier told me that 114 divided by 19 is 6, and that is correct. Okay, so now we know that each square foot of sod costs $6. Okay, so if the sod costs $6, right, I can plug it into that equation there. So 54 equals 5 times 6 plus 8g. Just bringing that down. 54 equals 30 plus 8g. subtract both sides by 30. We are going to make this a little bit smaller so we can actually do the rest of it. This will be 24 equals 8G. Divide both sides by 8. We get 3 equals G. So that's $3 per geranium, $6 per square foot of grass sod. And that looks like it's going to be answer D here. Okay. Sorry about that mix up again. You guys get to learn from my mistakes because I'm not going to edit them out. It takes too much time. All right. So now for number 10, it says Alberto and Jose each improved their yards by planting rose bushes and geraniums. I really hope I'm saying that right because I keep saying it. They bought their supplies from the same store. Alberto spent $115 on 5 rose bushes and 6 geraniums, while Jose spent $274 on 14 rose bushes and 12 geraniums. Find the cost of 1 rose bush and the cost of 1 geranium. So again, we have to set up a system of equations. So for Alberto, he spent $115 total, and he had bought 5 rose bushes and 6 geraniums. Okay, it doesn't matter if you use capital or lowercase r. I don't know why I did capital. There we go. And then Jose spent $274 total on 14 rose bushes and 12 geraniums. He's buying a lot of stuff. So I would again use the process of elimination, and this time I would multiply the top by -2. All right, so if I do this, -2 times 115 will be -230. -2 times 5r would be -10r. And -2 times 6G is going to be -12G. So you can see I'm trying to eliminate my geraniums again. It just worked out that way. So this is 274 equals 14R plus 12G. Okay, so now I'm going to go through the process of elimination here. So -12G plus 12G, cancel those out. I'm going to get 4R here. -230 plus 274 is going to be a positive 44. So now if I divide both sides by 4, I'm going to get R equals 11. So it's $11 per rose bush. And you guys can already see that's going to be answer C, but let's still double check, okay? I'm going to use Alberto's equation to check my answer just because it's shorter. So 115 equals 5, and instead of R here, I'm going to put an 11 for rose bush price plus 6G. So this is going to be 55, 15 equals 55 plus 6G. I'm going to subtract 55 from both sides. So I'm going to get, this will be 60, right? 115 minus 55. Yep, 60 equals 6G. So now I'm going to go ahead and divide both sides by 6. Okay, and I'm going to get 10 equals G. All right, so then that means it's $10 there per geranium. Okay. All right, so your answer is going to be C, $11 per rose bush and $10 per geranium. All right. So now we're moving on to factoring. Okay, so your first step when factoring, I would always rewrite it on a separate piece of paper or something. Okay, so here I want to see if they have a greatest common factor. The one that you want to check is 3 because it's the one that's out in front. So basically you want to divide 18 by 3 and make sure 18 divided by 3, it's 6. So it is divisible by 3, and then 81 divided by 3 is 27. So yes, they're both divisible by 3. So our first step here is to pull out a GCF, and in this case it's 3. So in order to do that, you have to divide each section by a 3. Okay, so I'm going to get x squared minus 6x minus 27. So now I'm going to factor what's inside. Okay, so factor with a diamond and area model. All right, just what's inside. So I'm going to have negative 27x squared, and then the negative 6x goes on the bottom here. So my two factors for 27 are going to be 9 and 3 for this one. So 9x and 3x. Actually, here, let me color code a little bit. So 9x and 3x. And I have to figure out, okay, which one of those needs to be negative to get a negative 6? It's going to have to be negative 9x. Okay, so now if we were to put these into an area model, all right, I'm only putting in what I had factored. So negative 27 is going to go on the bottom right. My pen's going all crazy on me. And then the x squared is going to go up top left. And the other two boxes are for the factors that I got. So I got negative 9x and 3x. Okay. So now I'm going to put x squared, negative 27, negative 9x, 3x. So again, please make sure you're pausing and doing this on your own, okay? So what you should get is x minus 9, x plus 3. All right, so then the factored form, the final factored form needs to have my GCF of 3 in there. All right, and then times my two factors, I got x minus 9 and x plus 3. So if you had forgotten the GCF, you might have selected A, but that would be wrong because you had factored out a 3. So this answer is going to be B. Okay, so now let's go and look at number 12. Okay, so I'm going to see here. Let's see if 136 is divisible by 14. I just always try to divide it by that first one. Ooh, no, I got a decimal. So 136 is not divisible by 14. So now I would try 2. It looks like everything's an even number. So 14 divided by 2, 7, good. 136 divided by 2, 68. 90 divided by 2 is 45. Okay, so my GCF here is a 2 so far. And we might see like later on that we can factor out more, but luckily this is multiple choice, so I don't see any other GCFs besides a 2. So that's kind of a little cheat for you guys with the multiple choice. So here it's going to be 2. Divide each piece by 2. So it's going to be 2 times 7r squared plus 68r plus 45. So now I'm just going to factor what is inside, okay? So if I factor the inside, 7 times 45, let's see here. 7 times 45 is 315. And then that's r squared, and then the 68r goes on the bottom. So we have to try to figure out what two things multiply to 315 and add to 68. So we're definitely going to set up a factor chart here for 315. I know it's not divisible by 2, so I'm not going to be able to put a 2 in there. But I'm going to see what it is by 3. I think it's going to be 105. So if we do 315 divided by 3, and sorry guys, I would be doing it on the iPad, but it doesn't let me split screen anymore while I'm recording. All right, so then I'd have 3 times 105. You can see if 4 goes into it. I don't believe it does, but let's try 315 divided by 4. Nope, that's a decimal. What about by 5? Yes. This is good. 5 times 63 gives me 315. 5 plus 63 equals 68. So those are the two factors. That one was nice. Okay, so we have 5 times 63. So let's set up our area model. I'm going to color code again, just in case that helps one of you. Top left, bottom right, and left, top right. Okay. Oops, sorry, these are each an R. Dear, my pen's not working as well as it should be. 5R, R, okay. So I have 7R squared, 45, 5R, and 63R. All right, so these are going to be a little bit more difficult than usual just because that's 7R squared, but just be very careful whenever you're factoring. If I'm looking at these two, their only common factor is an R. It's going to be an R there. And then here, I know I got to multiply something by R to get 7 squared, and both 7 and 63 are divisible by 7. So the common factor there is 7R. And then here, I'm going to have to multiply R by something to get 5R, and the GCF between 5 and 45 is 5, and it's going to be a positive 5. And then the last thing over here, I have to multiply something by 7r to get 63r and something by 5 to get 45. And the GCF between 63 and 45 is 9. So your final answer is going to be 2 times 7r plus 5 times r plus 9. And it looks like that's going to be answer choice A. Okay. These are big ones. All right. So let's go and see what's next. Solve each equation by factoring. All right, so let's see if this one's factorable. If we have n squared plus 6n plus 8 equals 0. All right, so if I multiply these two, 8n squared, 6n goes on the bottom. Okay, if you want to think about what two factors multiply to get that. Okay, hopefully you see it's 4n and 2n. Okay, then again, I'm going to keep on color coding for my people who need that. Oops. Oh, and just a reminder that I always put the B term in the bottom of the diamond in case you forgot about what goes there, but that's where it's coming from, okay? It's always the BX term. So here I have n squared, 8, 4n, and 2n. So this one's going to be n plus 2, and this one will be n plus 4. So since it says solve it, you have to now take each of those and use the zero product property to solve for the x-intercept. So you set each factor equal to 0. Oops, sorry. N plus 4 equals 0. So now if I were to solve for n minus 2, I'm going to get n equals negative 2 minus 4 minus 4. N equals negative 4. So my x-intercepts would be the points negative 2 comma 0 and negative 4 comma 0. So it looks like D. So these little squiggly brackets are just saying 4 and negative 2, basically. But they use a comma right here. So it's not saying that that's the point on the graph. It's just saying it's those two things are the x-intercepts. Okay, so number 13 is D. Number 14, it looks like I'm going to be able to factor out a 2. Let's see what happens whenever I do that. So it looks like I have a GCF of 2. So I'm going to have 2 times, if I divide each of these by 2, it's going to be v squared minus 64. And now I notice that this is a difference of perfect squares here. So this is going to be v plus 8 times v minus 8. Okay, so using the zero product property, I don't have to worry about this 2 out here anymore because there's no v there to solve for. So I just have to set v plus 8 equal to 0 and v minus 8 equal to 0. So now if I solve for my x-intercepts, I'm going to get v equals negative 8 and add 8 to both sides here. V equals positive 8. So it looks like this answer is B. Okay. All right. Solve each equation with the quadratic formula. Okay, so the quadratic formula is as follows. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So the first thing you gotta do is figure out what a, b, and c are. So in this one here, a is 6, b is 5, c is negative 144. Okay, so here I'm going to have x equals negative 5 plus or minus 5 squared minus 4 times 6 times negative 144 all over 2 times 6. Now I'm going to go ahead and color code for you just so you can see what I did here. So the b's, oops, that's not b. I plugged in right here and here, the 5. Okay, the a, I plugged in here. So those are the a's. Okay, that's a 6 there, not a b. And then the c's, oops, I forgot one of the a's down there. The c's got plugged in right here, okay? And this one was an A here. All right, I'm just going to copy that to use for later. Okay, so now what I'm going to go and do and start simplifying. So this is going to be x equals -5 plus or minus 5 squared is 25. Sorry, plus or minus the square root 25. And then -4 times 6 times -144 equals 3,456 all over 12. 2 times 6 is 12. Okay. I'm just going to make these just a little bit smaller. There we go. All right, so now I have to do 3,456 plus 25. Okay. So I'm going to get x equals -5 plus or minus the square root of 3,481 all over 12. So let's see if this is a perfect square root. So we got to see if 3,481 is a perfect square root. So I'm going to do the square root in my calculator of 3,481. And it is a perfect square. So I'm going to get 59. Okay. So let's see here. I'm going to have x equals -5 plus or minus 59 all over 12. So the square root of 3,481 is 59. So now I got to split up that plus and minus to actually solve for my x value. So I'm going to have x equals -5 plus 59 all over 12, and x equals -5 minus 59 all over 12. Okay, so this is going to be 54 over 12. If you were to divide top and bottom, I believe they're both divisible by 6. Okay, this is going to be 9 over 2, or 4.5. It just depends on what the answer choices are. This one will be -64 over 12. These two are both divisible by 4. So this will be -16 over 3. All right, 16 divided by 3 is going to be a repeating decimal. Yeah, that's what I thought. So let's see if any of those are my answer choices here. Yeah, I have 9 over 2 and -16 over 3. Answer A. Okay, so that is that. I'm going to move this over here. All right, so that's how you guys would do that one with the quadratic formula. Okay, I'm going to go ahead and go over to this one now. I'm going to move this up here just so I have more room to work. All right, so first we have to determine A, B, and C. Okay, so A's I had as green. So 4 is A. -12 is B. You have to include that negative. And -19 is C. Okay. So now I'm going to go and plug them all in. So I'm going to have x equals -12 plus or minus the square root of -12 squared minus 4 times -19 all over 2 times 4. So I'm going to go and color code again. So the C was this -19. The B's were the -12s. And the A's were the +4s that I plugged in. Okay, so here I have x equals +12 plus or minus the square root of 144. And then 4 times 19 is going to be 304, and it's going to be a positive because I had -4 times -19 there, all over 8. 2 times 4 is 8. So 304 plus 144 is 448. So x equals 12 plus or minus square root of 448 all over 8. So if you try to take the square root of 448 in your calculator, you're going to get 21.1660149 and so on. It's a long decimal. So what you want to see is, are there any perfect square factors? So my perfect squares are like 1, 4, 9, 16, 25, 36, 49, 7 squared, 64, 81, and so on. So I know 4 goes into 448. 448 divided by 4 is 112. Okay, but then I know that 4 can go into 112 again. So I'm going to see if 448 is divisible by the 16 there, that perfect square. So 448 divided by 16, it is, it's going to be 28. But then I realize 28 is also divisible by 4. So now I'm going to go even a step further and multiply the 16 by 4 and see, okay, well then is 448 divisible by 64? Right? So now if I try 448 divided by 64, I get 7. So here's what I mean by that. This means now I can rewrite x equals 12 plus or minus the square root of 64 times the square root of 7 all over 8. So now what this is going to do is it's going to let me simplify down that radical there, okay? The square root of 64 is 8, and this is all because 64 times 7 is 448. That's why I could do that, okay? So I'm going to go and move this off to the side. These were just my little notes, my thinking notes here, okay? Just my notes. All right. So the square root of 64 is 8, so I'm going to go and rewrite this over here. So x equals 12 plus or minus 8 square root of 7 all over 8. Okay, so the way that you can simplify this is you can split up that plus or minus here, like 12 over 8 plus or minus 8 root 7 over 8, like that. So you can do that anytime you have two numbers up top being added or subtracted divided by the same number. So now this goes down to, those are both divisible by 4, so I have 3 halves plus or minus, these cancel out, plus or minus root 7. Hold on. Did I do something wrong again? It looks like I might have. Ooh, this is going to be hard to find. Ay. Did 64, that's 8, so that should be 1 root 7. So it should be, I'm thinking the answer is B here, but I'm trying to figure out how they were, oh, I see here. Okay, so they didn't like it that it was separated like this. Okay, so in order to make it not separated like that, what they did was basically, instead of dividing out those 8s here, they were just like, oh, you can divide those by 4 as well. So then it will be 2 over root 7 over 2, which would then be 3 plus or minus 2 root 7 all over 2. So they basically wanted to keep it as one fraction. So my other answer, 3 over 2 plus or minus root 7, is correct. It is correct. But they wanted it to be in a fraction form. In order to do that, they had to keep at least like 2 over 2 here, you know, to simplify out that bottom denominator. So the answer is B. Okay, so that looks like it's it for the review. I hope you learned from